Okay, this is the beginning of the last target of this unit. We're going to be solving algebraic equations in one variable. This is the first day we're doing it. Tomorrow we're going to be doing inequalities. All right, so let's take a look at everything we've learned so far. And we're just going to kind of put it together now. So, in this example, we've got 15 plus 4a equals 9a minus 5. So remember, the first thing you want to do is collect like terms on either side. Okay, so to do that, remember you move variables over to one side and your numbers over to the other side. So we are going to, well, let's take negative 9a from both sides so we can get all our a's over on the left. So by doing that, it allows me to get rid of this because that becomes 0. And 4 minus 9a is negative 5a. Now you could have done 15 minus 5a, whichever you prefer. It doesn't matter to me as long as you know that this is a negative number. Okay, your next step is going to be to move your 15 over to the other side by zeroing it out on this side and subtracting 15 over here. Okay, this becomes 0. You still have your negative 5a over here. And then negative 5 and negative 15 is negative 20. All right, and last, we need to divide by negative 5. Since we have negative 5 times a is being multiplied by negative 5, we divide by negative 5. Now remember, a negative divided by a negative or a negative times a negative is always going to be a positive. So a equals 4, as I wrote down here. For this first one, maybe the first few, I want to take the stress of you having to figure out the answer out of it and more or less focus on the process. So process again, first collect like terms. Second, get the variable by itself. You do that by doing addition or subtraction. First, where we do the collect the like terms, and then you either have to multiply or divide the variable to get it by itself. So get variable by itself. Okay. And then what do you do once you have your answer? Because here's our answer, a equals 4. But you're not done. No. We want to go ahead and check your answer. So since we said a equals 4, in place of a, we're going to put 4. 15 plus 4 times 4, which is 16. And then 9 times 4, which is 36, minus 5. 15 and 16 is 31. 36 minus 5 is 31. So since both sides are equal, we know our solution works. 31 equals 31. All right, next, in the second example, what are we going to do first here? Take a minute, think about it. You thinking? All right, first things first, get rid of grouping symbols. Get rid of grouping symbols. So you can do this one of two ways. You can, if this was a fraction, you could try and multiply by the reciprocal like we went over. In this case, I would just distribute first. So 6 times t is 6t. 6 times 3 is 18. And then we keep the 4t minus 12 on this side. Next, again, collect like terms on either side. So the first thing you want to do, I would move my 6t over to the, and you know what? Let's move the 4t over this side, to the right side this time and put our variables on the right. So we'll subtract 4t from both sides. Now I'm doing this for two reasons. One, to show you it doesn't matter what side you put the variable on. And two, because when I do this, I get a positive variable over here. So that's one less thing to worry about with negatives. Okay? Okay, so next, I need to do that with my numbers. So since my variables are on this side, I'm going to move the numbers to the other side. These zero out. And negative 12, negative 18 is negative 30. and then solve for the variable. In this case, it's t. Okay, so we have 2 times t, which means we divide by t, or 2, which gives us t equals negative 15. That's our answer. Now let's see if it checks out. 4 times negative 15 minus 12 should equal 6 times negative 15 plus 3. So 4 times negative 15 is negative 60 minus 12. Now, I would do the parentheses first. So negative 15 plus 3 is negative 12. So that's 6 times negative 12, which is going to give you negative 72. Negative 72. So it's negative 60 minus 12, negative 72. Well, whenever I have something like this, where it's a negative number minus a negative number, it helps me at least to think of it as negative 60 plus negative 12. Because then I can say, well, the signs are the same, I just add and keep the sign. And by doing that, they're both negative, so it's negative, and then 60 plus 12 is 72. So negative 72 does equal negative 72. The answer checks out. Okay, next one. We have 6d minus 6 equals 3/4 4d plus 8. So I'm not going to write down the steps, but I am going to show you that you can do this one of two ways. You see the fraction, and because of what we did last week, you might say, well, I want to multiply both sides by 4/3, which you can do. Keep in mind, though, it might be easier to just try and distribute it. Because remember, the denominator, if you can divide these numbers that you're going to be distributing it to by the denominator, you can just cancel some of this stuff out. So doing that, we could just keep the left side the same. And then we've got this. Does 4 go into 4? Yes, it does. So that would leave me with 3 and d, because the two 4s, basically 4 divided by 4 is 1. I don't need to write that. Okay? And that would just leave the d there. And does 4 go into 8? Yep, it goes into 8 2 times. So because it goes into both, now that's the thing, it has to go into both. Otherwise, you would want to try multiplying by the reciprocal and seeing if that's easier. So now I can simplify that to 3 times d plus 2, which then you distribute, giving you 3d plus 6. Collect your terms on either side, so I'm going to subtract, oh, that's a messy d. Subtract 3d from both sides. So that'll give me 3d minus 6 equals 6. And then I'm going to add 6 to both sides, which is going to give me 3d equals 12. Because now I've got my variable on one side with its coefficient and my number by itself on the other side. And since 3 is being multiplied by d, I'm going to divide by 3. And since I did it to this side, I have to do it to this side. And that becomes d equals 12 over 3 reduces to 4. Okay, and does 4 work? 6 times 4 minus 6 equals 3/4 times 4 times 4 plus 8. So this would be 24 minus 6 equals 3/4. 4 times 4 is 16, plus 8 is 24. Okay. 24 minus 6, 18. Over here, I've got a 4 in the denominator, and I'm multiplying by 24, so let me see if 4 goes into 24, and it does. It goes into 24 6 times. So now I have 3 times 6, which is 18, so it checks out. Now let's go back and just see, could I have done the same thing, but instead of, canceling the 4's out, let's say you wanted to multiply by the reciprocal of the 3/4. you would have had 6d minus 6 equals 3/4 times 4d plus 8. And both sides would be being multiplied by 4/3. The 4's cancel out over here because denominator, numerator. Over here the 3's cancel out, numerator, denominator. And here I would just be going back to this. Does 3 go into what's inside the parentheses? And it actually does. 3 goes into 6 twice. And since they're both 6, it'd be 2d minus 2 equals 4d plus 8. Now, keep in mind, this is just a different way of doing it. If you're good with the first one, good. Just listen and you don't have to worry so much about this. It's whichever way you prefer. Okay, and then you would distribute this, which would give you 8d minus 8 equals 4d plus 8. Get your variables on one side, your numbers on the other. Now notice I'm just kind of doing it all at once. Once you get good, you can do that and save yourself a little bit of space, which will leave you with 4d equals 16, and again, d equals 4, because you divide both sides by 4. So you come up with the same answer either way, whichever you prefer. Last but not least, now, this problem is not going to have a solution. I'm going to show you why. Because when you distribute, which would be your first step, since you see the parentheses, you get 3a plus 9 equals 3a plus 27. Okay, so they both have 3a. Okay, but this one's adding 9 and this one's adding 27. So since this part is the same in both, but this part is different on either side, then it can't be the same number because a is only going to be one thing. So let's say, for example, a was 1. 3 times 1 is 3 plus 9 is 12. Over here, 3 times 1 is 3 plus 27 is 30. 12 does not equal 30. Now let's say you didn't recognize that. That's fine. It's not a big deal. Get my variables on one side. So I'd have 3a plus 9 equals 3a plus 27. Subtract 3a from both sides. Subtract 9 from both sides. That cancels out. Oh look, that cancels out too, leaving me with just 0 on this side because the two 9's cancel out. But 27 minus 9 is 18. Does 0 equal 18? No. So no solution. So even if you get down to here and your variables are gone, if it's not a true statement, you have no solution. Now the opposite of that would be this. Let's say I've got 10m minus 4 equals negative 2 times the quantity 2 minus 5m. Okay, you're going to end up with something that's identical on both sides, and if this is the case, then we call this an identity. Okay, so let's say we distribute it first, which you should do. You get 10m minus 4 equals negative 2 times 2 is negative 4. Negative 2 times negative 5 is positive 10m. Now I could reverse this if I want, so that it's, because negative 4 plus 10m is the same as 10m minus 4. Because remember, it's the number in whatever signs to the left. So I have a negative 4 and a positive 10m. As long as I'm adding, I can flip it around without a problem. Which this is the same thing that I have over here. And since 10m minus 4 equals 10m minus 4, that's true. It works. Okay? They are both identical on either side, and we would call this identity. But again, let's say that you didn't realize it, and you wanted to get your variables on one side, your numbers on the other. You'd subtract 10m from both sides, add 4 to both sides. That would give you 0. That would be 0. That would be 0. That would be 0. So you'd have 0 plus 0 on both sides. Okay, looks weird. 0 equals 0, but 0 does equal 0, so that's true. So that would be an identity.